Hello. Well, I've just taken delivery of this worm-driven electric motor which we might use to control the rudder. It's a JGY-370 6 volts 10 RPM device. I think the reduction ratio is 588 inside this gearbox. It seems to be about 80 millimeters long, 30 millimeters wide, 22 or so millimeters tall. The shaft has a flat on it, and also it's tapped with something which I don't know. It seems to be made out of die-cast aluminium. Here's the motor, here's the gearbox. The comparison, that's an AS17 type servo. The motor seems to weigh 154 grams. This motor is basically a 6 volt motor, so if we drive it with exactly 6 volts, we'll see how much current it takes. And I'll just stick this on the top so that we can see it going around more easily. So that's rotating clockwise and taking between 108 and 116 milliamps, about 115 milliamps. And if I count the revs, that's 5.9 seconds for one rev, which is 10 RPM, as we thought. And of course, if you reverse the polarity of the DC drive, then it just goes the other way, and presumably at the same speed. Let's just check that. Yes, that's 6 seconds for one rev. Now, the reason I chose this motor is because it's the only one that is rated at 6 volts. All the other motors are rated at 12 volts or more, which would be inconvenient for the solar power, I thought. So probably we'd be running this motor, in fact, at below 5 volts, probably more like 4.4, because we have to allow for the fact that switching may drop some voltage, particularly if it's electronic. So let's just try it at that. Still runs, of course, at 4 volts, but takes only 97 milliamps instead of the 116. And if we measure the speed, it's more like 8 seconds for one rev when running at 4.4 volts. If we try and stall it, I can't actually stall it with my fingers, but the current goes up to 125 milliamps even at 4.4 volts. So it's quite a powerful motor, and certainly no seaweed is going to stop the rudder turning if this motor was turning the rudder. Now, of course, I suppose you want to see what it looks like inside. So there are just these 4 screws to remove. Right, I've got the screws out. So now I'm going to turn it upside down, because last time I did this some things fell out. So I've got it upside down now, and you can see that in fact it just comes away quite easily, and we've got lots of reduction gears driving the shaft, and the motor itself has a worm gear on it. These reduction gears are steel or brass, as you can see. The shafts are all steel, and they run in aluminium holes in the casting, except for this one here, the main output bearing, if you like, which looks to me like a small ball bearing that's been pressed into this housing. So it looks to me quite a nice construction. The main problem with this as a possible solution for driving the rudder is that this is not a brushless motor. It's a DC brushed motor. If we wanted a brushless one, we'd have to go to the next size up, which is the 12-volt one, which causes this voltage problem, unless we redesign all the power control to operate on 12 volts. Another point that I should make about this motor is it only has one shaft. So what I could do is fit a Hall effect rotation sensor on the end of this, and a bit lower down I could fit a lever which would drive the rudder. There are other variants of this motor which I've seen on eBay where the shaft comes out at both ends. Holy smoke, why didn't I do that up first? The shaft comes out both ends because there's a hole here, and that would be more suitable really, because you could have the rotation sensor on one end and the rudder connected directly on the other end. Right, now this motor of course has a permanent magnet in it, so it's going to affect the compass. So here is my military type compass, and if I just adjust that so yes, we know which direction it's pointing. Zoom out a bit. The question is, if I bring the motor near, does it move the compass? Well, quite clearly it does if I'm close, but by experiment I find that there's virtually no influence at this distance, which is 18 centimeters. So long as the motor is 18 centimeters away from the compass, we should be all right. Well, that's enough about the JGY-370 motor. I think it's a possible candidate for driving the rudder. I don't see how it could be any less reliable than a plastic servo, but it does have the disadvantage of not being a brushless motor.